Founded in 1937, Michigan State University Federal Credit Union offers financial services to students, faculty, and staff of Michigan State and Oakland University. With over $4.1 billion in assets and 265,000 plus members, MSUFCU is the largest university-based credit union in the world. With a large quantity of wealth managed comes a sizable responsibility of protecting member assets against fraud. In the past year, U.S. consumers experienced over $8 billion in losses due to payment card fraud. MSUFCU protects its members from fraud by monitoring almost 40 million transactions from its members annually. Our transaction anomaly detection system seeks to help MSUFCU leverage its abundance of transaction data to provide value back to members. This value comes in the form of machine learning anomaly detection, recurring payment tracking, location-based anomaly detection, and member spending visualizations. Let's take a look at our anomaly detection module in action. We begin by taking a look at the interaction between an MSU-FCU member and our system and a simulation of day-to-day spending habits. As an MSU-FCU member goes about their day-to-day lives, our module aggregates and analyzes transaction data to detect and alert users of fraudulent payments, as well as provide members with insights into personalized spending habits. Members interact with our system through our iOS, Android, and web portals. Here we can see our Android front end. After logging in, a member can view a list of recent transactions and can look at details about individual transactions. Payments which are consistent with a member's spending habits have no special indicators. For a more in-depth look into spending habits, a member can log on to our web portal. Here we provide similar functionality to our Android front end by allowing users to view a list of transactions as well as details about individual payments. In addition to these features, our web portal allows members to view their top 5 most frequent retailers as well as the amounts spent at these locations. In addition to monitoring individual transactions, our anomaly detection system groups and analyzes trends in spending to alert users of increasing recurring payments. We first take a look at an MSU-FCU member with a recurring payment to Netflix and look at the impact of fluctuating prices for this payment over time. Our first case involves a recurring charge to Caleb's account, which is consistent with previous values. In this case, the charge appears on his account as a normal transaction and all is well. Our second case involves a recurring charge, which signals an increase from previous amounts. If we detect that Netflix has charged Caleb more than usual, the transaction is brought to Caleb's attention via alerts on our member portals. If Caleb decides that this increase in price is unwanted, he can pull up details about the transaction and consult Netflix about the charge. If Caleb decides that this increase in price is okay, such as in the case where Caleb willingly upgraded his Netflix plan to a higher tier, he can log on to our web portal, locate the flagged recurring payment, and signal that this price increase is okay. This action will set the new normal value for a Netflix payment to this higher amount. The next component to our anomaly detection system is machine learning and location-based fraud classification. When a transaction enters our system from a physical retailer, we first compare the location and timestamps of the new transaction to the most recent transaction on the account. We determine whether it's possible for this new transaction to have occurred, and if the distance is too far to have reasonably traveled, it is labeled as fraud. After checking the location of a payment, we pre-process the transaction data, then we run this data through 4 different machine learning models and apply a support vector classifier to determine whether a payment is fraudulent given past examples of fraudulent payments to learn from. Our model correctly flags 80% of fraudulent cases and has a false positive rate of 0.1%. In addition to our machine learning classifiers, we also have probabilistic models to give a percent confidence that a transaction is fraudulent. If our system determines that a payment has between a 50 to 85% chance of being fraudulent, this payment is sent to our admin portal, where an MSUFCU employee can view these cases, look at similar transactions, and alert users of these fraudulent payments. Our anomaly detection system was built using a Django web server deployed using Amazon Web Services' Elastic Beanstalk. Our transaction data is stored in a MySQL database, and this data was analyzed and flagged accordingly with Python scripts located in our Django project. The transaction information is passed to our iOS, Android, and web frontends using a Django REST API. Our transaction anomaly detection system hopes to provide MSUFCU members with better insights into spending habits as well as protection against payment card fraud. Our solution seeks to help MSUFCU members protect their assets and aid in making better financial decisions.